Japan is home to as many as 1,500 varieties of seaweed, yet only about 60 of them actually make it to the dinner table. Among these, nori is arguably the most famous. The thin, crisp seaweed that wraps around the sushi rolls known the world over. However, when first harvested, nori consists merely of wet, soft clumps of seaweed, a far cry from the neat, square sheets found in supermarkets. To achieve this transformation, the seaweed undergoes a multi-step process, most notably a sheet-forming technique derived from traditional Japanese papermaking. So, how exactly is seaweed from the ocean transformed into the millions of nori sheets used for sushi and kimbap? Let's find out in today's video. Seaweed has long been considered a distinctive part of the Japanese diet. Not only is it low in calories, but it also provides fiber, protein, and various minerals, such as iron, calcium, and magnesium, and is notably rich in iodine, an element essential for the body to produce thyroid hormones. The fiber content supports digestive health, while certain natural compounds found in seaweed are being studied for their potential benefits regarding blood pressure and cardiovascular health. However, this resource is facing a different challenge. Natural seaweed beds in Japan have significantly declined in recent decades, partly due to rising seawater temperatures and the impact of seaweed consuming marine life. To maintain the supply, Japan is not only expanding cultivation, but also experimenting with new methods. For kombu, ropes can be suspended vertically into the sea to utilize more space. As for nori, the journey to becoming the sheets of seaweed used for sushi begins right at offshore farms. The journey of a sheet of nori does not begin in a factory, but rather on massive nets stretched across the open sea. Instead of waiting for seaweed to grow wild, cultivators actively seed specialized nets with nori spores and then transfer them to coastal waters to mature. Depending on local marine conditions, the nets are either anchored between poles or attached to floating buoy systems. After approximately 40 to 50 days, the nori is ready for its first harvest. Nowadays, rather than harvesting entirely by hand, many farms employ specialized harvesting boats. As the boat moves along the rows of nets, a cutting system gathers the mature seaweed while leaving the rest to continue growing. Interestingly, the freshly harvested nori is already an edible form of seaweed. Yet, if you were to see the sodden clumps of seaweed just pulled from the ocean, would you dare to try a bite right then and there? Immediately after the boat stock, the fresh nori is gathered into large baskets or sacks and quickly loaded onto trucks. Since the freshly harvested seaweed retains a significant amount of water, each container can be quite heavy. A single basket of wet seaweed weighs approximately 90 pounds, and a truck typically carries about 18 baskets of the raw material per trip. Because fresh nori deteriorates rapidly after harvest, the unloading and transport processes are carried out swiftly to ensure the material moves quickly to the cleaning and processing stages. Upon arrival at the processing facility, nori may still carry sand, mud, seaweed fragments, and other minor marine impurities. The raw material is fed into large tanks filled with clean water, where an agitation system operates at a relatively low speed, typically around 60 revolutions per minute. The resulting water vortex loosens the wet seaweed mass and keeps it in constant motion, facilitating the separation of sand and foreign matter while minimizing damage to the delicate seaweed sheets. A washing cycle generally lasts about 10 minutes, depending on the quantity of seaweed, the level of contamination, and the system's design. Subsequently, the nori may pass through one or more additional clean water tanks and across screens or foreign object separators to remove any remaining sand, shell fragments, and debris. After being washed, the fresh nori is fed into a specialized cutting machine. Inside the machine, a shaft fitted with multiple blades rotates continuously, drawing the seaweed through the cutting zone and chopping it into short segments. In one machine design, the shaft spins at approximately 600 revolutions per minute, performing thousands of cuts in a very short time. The nori typically undergoes a preliminary coarse cut, reducing long sheets to about 4 inches in length, before being chopped into even smaller pieces. The process takes place in water, allowing the nori pieces to remain separate and circulate through the cutting system. Few people realize that the square sheets of nori used for sushi rolls are created using a process remarkably similar to papermaking. In the traditional method, finely chopped nori is mixed with water to create a thin slurry. An artisan pours this mixture onto a bamboo or wooden frame covered with fine mesh and gently spreads it evenly. Water drains through the mesh, while the small seaweed fragments interlock and settle on the surface, forming a thin layer. In modern factories, manual labor is replaced by a system featuring a series of rectangular mesh molds mounted on a conveyor belt. The nori is cut into pieces roughly 1/8 of an inch in size, mixed thoroughly with water, and pumped to a dispensing unit. As each row of molds reaches the forming station, the machine dispenses approximately 12 ounces of the nori water mixture into each mold. The mixture is rapidly spread across the entire surface. Water drains through thousands of mesh openings, leaving the nori fragments behind as a thin, uniform layer. The result is a series of standard-sized nori sheets, approximately 7.5 by 8.3 inches, resting neatly on the molds, much like freshly formed sheets of paper. As for you, if you had a sheet of nori right in front of you, would you choose to roll sushi, eat it with rice, or simply snack on it as is? The newly formed nori sheet still retains a significant amount of water within the spaces between the seaweed fragments. Consequently, the mesh molds move directly into a dewatering press, where a thick, porous sponge presses against the surface to extract excess water from the seaweed layer. In high-capacity production lines, the system may be configured to arrange approximately 10 nori sheets, allowing for simultaneous processing. Each sheet typically undergoes a primary dewatering press cycle. The sponge descends for a few seconds, drawing water through the seaweed layer and the underlying mesh, before retracting to allow the mold to advance. Following this pressing stage, the free water between the seaweed fragments has been substantially removed. The nori sheet becomes thinner, flatter, and more cohesive, yet retains enough moisture to avoid becoming brittle or cracking as it moves along the production line. Still resting on their mesh frames, the moist nori sheets are fed into the drying chamber of an automated production machine. The drying process is controlled to ensure gradual moisture loss and uniform drying of the nori sheet from the edges to the center. According to Japanese industry technical specifications, the finished product typically retains a moisture content of approximately 10% after drying. Upon exiting the dryer, each sheet of nori is placed onto an automated inspection conveyor. Here, an optical system utilizing CCD cameras captures and analyzes every sheet to detect irregularities such as holes, irregular edges, tears, or foreign objects embedded within the seaweed. sheets that fail to meet requirements are automatically diverted from the production line, while compliant nori undergoes further sorting based on color, luster, and surface condition. In Japan, grading systems can categorize nori into multiple quality tiers. Some regions utilize approximately 10 characteristic categories and 8 distinct quality grades. Once the nori meets specifications, the sheets are counted, stacked, and fed into an automated packaging line. Depending on the specific product, the sheets may remain whole for sushi rolls, be cut in half for onigiri, or be sliced into strips prior to packaging. Dried nori is highly hygroscopic. Prolonged exposure to humid air can quickly cause the naturally crisp sheets to soften and lose quality. Consequently, they are sealed in high moisture barrier packaging, typically with a desiccant packet included. Batch codes and product information are printed on the packaging to ensure traceability. Thanks to being kept dry and airtight, some roasted nori products packaged in aluminum-based materials can have a shelf life of approximately 2 years at room temperature. From the soft seaweed fronds clinging to ocean nets to the thin, crisp, square sheets of nori, the familiar wrap used for sushi is actually the result of a meticulously controlled production process. What is truly fascinating is that, even though modern machinery can now automatically cut, shape, press, dry, and inspect nori on a massive scale, the core principles behind these operations still bear the hallmarks of traditional Japanese papermaking techniques from centuries ago. As for you, do you typically use nori to roll sushi or kimbap, or do you enjoy it straight as a snack? Let us know in the comments and subscribe to the channel to keep exploring the intriguing production processes behind the familiar products in our daily lives.